Hey, what's up guys? Dave here from CNC3D. So today we're going to be doing a CNC Tech-Tips video. We are going to be learning all about limit switches and offsets. So this video specifically relates to our Nighthawk controller or to an xPROV5 controller and pretty much any other GRBL based CNC controller on the market. So let's just jump straight in. Today we're going to be working on our QB2 CNC that we have at our factory. This is a version 1 machine that does come with mechanical switches on the machine. And we're going to be talking a bit today about soft limits and hard limits and the difference between the two, and also the reasons why we do prefer soft limits on our machines as opposed to hard limits. So let's just jump straight in and take a closer look here at our QB2. We're going to take a look at where the limit switches are located on this machine, and then basically we're going to go and run some tests so you guys can see how the limit switches actually work. So here we are on our QB2 guys. So if we just take a look here at the front of the machine, so you'll notice that we do have a limit switch over here, and this is actually our X-axis limit switch that runs across the gantry. Now you will notice we do have a switch on this side, but we don't actually have a switch on the other side. And if we take a look around the side here, we have another limit switch. This is for the Y-axis. Now, this particular machine normally does have a fourth axis with it, so we don't actually have dual axis homing set up on our Nighthawk here for this. So there's no limit switch over on this side. And basically on our Z, we have a limit switch at the bottom of the Z axis that will trigger when this bearing block touches onto it. And then basically we don't have one at the top here at all. So let's go and have a look a little bit closer about how we do our limit switch configuration on our QB2s and explore soft limits first. Okay, so we're just here in our CNC3D Commander software. So the first thing that we're going to do is we're going to connect up to our QB2 CNC at our factory. So we've just got the IP address loaded in here. Let's just go ahead and connect. Now, the first thing that we're going to do is we are going to be homing our machine. Now, whenever you home your machine, it basically will attempt to travel to a particular location as far as it possibly can until it contacts a limit switch. Now, in our Commander software, we have made these breakouts very, very easy for GRBL users. So if you click on the Peripherals tab at the top here, you will see that there is a homing option within here. So we currently have it set up on this particular machine. We have made sure with this invert homing that basically we are moving in the correct direction that we need to for homing to complete. So if you do enable homing within Commander and then you go through and realize that basically it's not homing the right direction, you can quickly hit the emergency stop button and then unlock your controller, and then you can choose to invert that respective axis. Now, most typically what you will find is that your Z axis will raise to the highest possible point. So this is the safest possible position for your Z axis to be in because it's the furthest away from the bed and any possible materials. Now, with your X-axis and your Y-axis, in this particular case with this Nighthawk controller that we have on here, you can see that we have a specific homing order and that we are going to be doing Z first, and then we're going to be doing X and Y together. Now, your GRBL-based controller won't have access to this particular panel because it's not a feature built within the normal GRBL. Instead, you'll find that within the firmware for GRBL, you can actually set your homing order, and you can also choose whether or not you wish to do multiple axes at a time. So let's just go ahead here. We have our limit switches in place. So what should happen is our Z should raise up on this machine, and then our X and Y should make their way towards those respective limit switches that we covered earlier in the video. And so it should travel to the left on the X and move towards the front of the machine on the Y. So let's just hit the home machine button over here. Now, for those of you that don't know, within our CNC3D Commander software, we do have these limit switch trigger statuses down the bottom here. And basically our particular A axis right now is showing as basically activated because we don't have our fourth axis currently connected up to this machine. It's just running in 3-axis mode. So we can just ignore this particular alert here. But what you would have noticed during that homing cycle is that the X, Y, and Z lights would have illuminated during the homing process. So basically now the machine has come to a full stop and has fully homed here. So what we can do now is we can basically take a look at our soft limits. Now within Commander, if you look on the right hand side here under limit switch type, we've got it currently set to normally open, and we have enable soft limits ticked. So if you want to learn a little bit more about this, we do have these handy little buttons here. So what they essentially are is basically your machine knows that from the home position exactly how far it can travel on a respective axis. So if you take a look here next to the limit switch type, you've got maximum travel limits, and you can see that the X max travel is 760, the Y is 740, the Z is 108, and we've just left our A here as 5,000. So what that will mean is that from the homing position, it should actually basically not allow you to travel beyond 760 mil from that position. So what you will notice, or I guess what some people may expect, is that when you home your machine, all of these numbers here for the machine coordinates should theoretically be 0. So that essentially is actually correct, but what's actually happened, and the reason why it is showing 3 in here and -3 for Z, is because of our homing pull-off value over here on the side. So what this basically means is that once your machine goes to home, what it will do is it will go and touch the physical switch. The controller will recognize the press of that switch, and then in this case it will pull away from that switch by 3 millimeters just to make sure that it's no longer actually pressing on the switch itself. And so this way, when it completes the homing cycle, it touches the switch and backs off, then it knows that it's in a safe position because the switch has been depressed. So technically at this point in time, our current machine position after completing homing is in fact 3 millimeters from the actual 0 point. So if we were to go ahead now and we were to say put 1 millimeter in here, and we were to try to jog the machine closer to the front, you'll notice that it will physically move. And it's because we do have that space to get this down to 0. Now if I tap this again, we are pretty much right on that switch. If you have a look down the bottom here, we can actually see that that is physically triggered. And if we were to go ahead now and hit Y- again, you can see that it hasn't moved at all, and it's gone straight into an alarm. Now this particular alarm is a very, very common alarm that people do get on GRBL based controllers. So it's basically telling you that it has exceeded its soft limits. Now, we've done a lot of research on this, and we know the GRBL firmware quite intimately, and can confirm that really only 2 conditions can occur for this to happen. So the first one is that you have not homed your machine at least once at the start of the day. And the second possibility is that you've physically exceeded your travel limits. Now, there are some conditions where you may throw soft limit alarms without realizing, based on the way certain information is set up. For example, if you are trying to do a probing routine, you basically need to specify how far you will let it try to actually probe. And basically, if that number is greater than the current soft limit, then it will trigger this alarm automatically. So just be aware of that one as well. Now, a lot of people also didn't know too that you can actually click on these alarms when you are in alarm state, and it should give you a translation of the alarm. Just keep in mind that not all alarms do actually return the reason for the alarm. So if that's the case, the most common one is you've just connected to your machine at the start of the day and it automatically starts in an alarm state. You can just go ahead and hit the unlock button, and that should take you back to a normal condition. Now, we have actually caused a trigger on this alarm now. So what we'll do is we're going to hit the E-stop here, and we're going to unlock this controller. Now you'll see that we're back in idle, but we're still at this 0 position on Y. If we hit Y+, we've now depressed off that actual Y limit switch, and you can see that our position is exactly at 1 mil here. Now the same works if we try to go the other way. So if we take a look right now, our current, let's just look at X here. So X is currently at 3 mil. And if we have a look on the right here, our maximum travel distance is 760 millimeters. So if we were to, in this distance box here on the left, if we were to type in here, let's just go with let's go 750, which gives us about a 10 mil buffer there, and we can actually sail this machine all the way across to the other side. And as you can see, that motion has completed exactly as we would expect. Now, if we were to hit the X+ button again, you'll see that we've immediately gone into our alarm state and the machine has not even attempted moving. So again, we can just click on this alarm and we can see that it's definitely an alarm 2 that's been received. So again, we just have to hit our emergency stop and then hit the unlock button. And let's just go and sail this all the way back to the very start. And there we are, right back at the very start position. So let's talk about soft limits. So obviously the advantage of soft limits, and it's the technology that we do prefer to use on our machines. Basically, we tell the machine exactly how far it can move, and having our limit switches configured in the homing position allows us to basically set one side of that maximum travel. And once it does have that one side, then it immediately knows how far the other side is as well. So the reason why we prefer soft limits is because if you try to travel a distance beyond the capability of the machine, it'll just go straight into an alarm. Whereas if you could imagine if you had a machine and you had hard limits set up on there, so say for example, if you had this enable hard limits option ticked in here, what it will do is it will physically rely on the actual switches themselves in order to tell the machine that it has gone too far. So most typically, you would actually have another switch on the other side of each axis, which of course increases your wiring required to set it up and can potentially be another fail point. But the most important reason why we don't prefer to use hard limits is because think of it like a blind person driving a car. They don't actually know when they need to stop until they physically crash into something. So if you can imagine that your machine is traveling at full speed towards one axis, and it will definitely collide with the side of that machine, it will be approaching that limit switch at considerable speed with considerable momentum behind it as well. And in some cases, although the switch may stop the motion because the activation was detected, it may actually damage the limit switch if the machine cannot decelerate effectively after hitting the actual limit switch. Now, inductive limit switches, they typically have a bit of a sensing distance, which definitely makes things a lot easier, because in some cases that 1 to 3 mil buffer that they do have can usually give the machine enough time to decelerate. So the machine will actually attempt to decelerate the second that it does encounter one of those limit switches when you have hard limits on, but there is a large risk there that you still may potentially damage your switch, or the machine may actually collide with itself. So we highly recommend using soft limits as opposed to hard limits. So that is the main reason why. Now, it is important to note for a lot of GRBL users, and this is some feedback that we have heard from the community, if you are in here and you've got your limit switches and you've gone across and pressed each limit switch and you can see it physically illuminating over this side, you still need to tell the machine that you wish to use a particular type of limit. So if you were to have both of these boxes unticked and you were to update these settings, The limit switches essentially would serve no other purpose other than homing the machine, which means they actually will not stop anything from occurring. So definitely make sure that you do have at least one option selected within here. In our case, it's just the soft limits, which is what we prefer to use. So definitely pick one there, otherwise you might be very disappointed with what could happen to your machine if you don't. So, moving forward, that pretty much covers everything to do with limit switches at this stage, and you can see how they work. Now, the next thing for us to go ahead and take a look at is offsets. So this has been a very common question that we've received over time. Now, for those of you that do have a Nighthawk CNC controller, you will notice that there is this O section here, and it does say G54, so that is the current offset plane that we are in. Now you can also click on these little letters to find out information about them. So in this one, this is basically your current job offset. So with GRBL controllers and with our Nighthawk, if we go in the offsets tab, you'll see that we have 1, 2, 3, 4, 5, 6. So there's 6 different offsets, and it starts at G54 and goes to G59. Now, by default, when you turn your controller on at the start of the day, it will be in G54, and that will be the default job coordinate plane. So what we essentially are going to do now is we're going to take a look at how you can choose to leverage some of these offsets in order for you to be able to, let's say, for example, plan specific jobs. So you might have multiple little parts that you wish to do in a particular spot, and it's the same job every time. Theoretically, you could have 6 independent jigs set up on this machine, and you could leverage each one of these offsets. So the most important thing to cover when it comes to offsets is to figure out exactly what they are. So let's just go ahead and home our machine here. Now, by default, we know that we are already in G54, and we can see that our machine coordinates here are their respective numbers. What the actual offset is the actual offset away from the machine coordinate plane. So if we have a look just here, you can see that these numbers 103, 203, and 3, if we refresh these, you can see that they stay the same. Now, if we were to hit 0 job here right now, you can see that it has zeroed out our coordinates here. And then if we hit refresh offsets, you can see that these numbers have now changed to exactly what the machine coordinates currently are. And as a result, it has made the job coordinate 0, which is what you would normally do when you're going to start your job. Now, if we were to move this to another location, so say for example, we'll just go 100 mil here, and we'll go across, and we'll go forward. And then if we were to go and refresh these offsets, they're still the same. If we hit 0 job here, and we hit refresh offsets, you can see now that it has moved the 100 mil on X and Y forward. And as a result, your job coordinates are now 0. Now let's say, for example, that we wanted to work in a different coordinate plane. So we've just gone ahead and we've set our G54. So if we go to our Run Job tab, we'll go down the bottom into here, and we're just going to type in G55 and hit Send. And now you can see already that our X coordinate plane has actually changed here. And if we go into our offsets and we just refresh them, we can see the G55 is 403, 103, and -3. So what we can do is we can actually zero out at any position. So let's say, for example, if we jogged across another 100 millimeters, and we're going to zero our job out here, and then we can refresh our offsets, you can see that this X value has changed here already. And so basically then what we could do again is we could say go across again another 100 millimeters, and we could type in here G56 and hit Send. And then we could choose to zero out our job coordinates here as well. And then if we wanted to, we can do the same thing again. So let's just go ahead here and we'll go another 100 mil, and we'll go G57 and we'll hit Send. And now if we go into our offsets tab and refresh, you can see that it has respectively adjusted these numbers for us across on the y-axis. Now, what we'll do, on the x-axis I should say. So what we'll do is we're just going to go back and we're just going to home our machine just to get us into a random position. And then now, if we were to go into the Run Job tab down the bottom, let's just go back into G54. And then now, if we hit Go to 0xy, we should travel to our first G54 0 position. And then now, if we go down the bottom here and we put in G55, and hit Send, and then now we can go ahead and go to 0xy now that we know we're in G55, and it will move to that next position. Now let's just skip G56 and go straight to G57 and go to 0xy. And now we have actually returned back to our home position. Now you may be wondering why that has actually happened. And the reason for that is because if we look at G57, its offsets are actually 0, 0, and 0, which means it will always want to return to the actual home position. So you can go ahead and leverage these offsets. Some really good advantages is, let's say, for example, your business manufactures particular boxes, say ABS boxes, and you have 4 different sizes that you do work on. What you can actually do is you could have, for example, a static jig that your bed is made up of, and you can basically slot a box into a particular position. And if you wanted to work on that box, you've already got a pre-saved job, say for example on your Nighthawk controller on the SD card. You can basically travel directly to that location, and you can just start that particular job for that size box. And then if you need to do a different size box, you can set up a different offset that you can use specifically just for that box. Now this makes things really easy from a production standpoint. We have done a separate video regarding G28 and G30 and how you can leverage those locations. There will be a link in the description down the bottom for you to check out that video. Basically G28 and G30, they will actually persist within memory in your controller, whereas these offsets are rather casual. So if your controller is powered off for a few seconds, it will lose in memory what these positions were, and you will need to just go through and obviously set those up again if you need to. So just be aware of that when you're using these offsets, there is a chance that they may reset. If you're looking for something a little bit more permanent for your locations, G28 and G30 will persist in memory even if the controller is powered down, and can always be called whenever you would like to go to that location. So definitely check out that video if you want to learn more about G28 and G30. But let's just talk a little bit more about the offsets. So we have had a look at some of the benefits of them, where you can choose to basically set up different coordinate planes for different jobs. So if you wanted to have a particular spacing between one spot and another, you could easily just toggle through between the G54 and say G55, and hopefully it'll give you guys a bit of flexibility when you're working on your machines. So I hope this video has been informative for all of you today, and you've learnt a little bit more about limit switches and offsets within your controllers and how you can obviously leverage them. So, and of course, keep in mind that this particular box will not automatically update. You do need to hit the refresh offsets button down the bottom here. Now, obviously, if you change any of these values, you can hit update general offsets, and that will physically change the location of these. So say, for example, if we wanted to make this one 403, and let's make it 200, and we'll just hit update. So currently we're in G57, so if we go back over to here, and let's say, for example, we'll go to G54 and send, and then we will go to 0xy, and then if we now change this to G57 and hit send, we can now go to 0xy, and as you can see, X and Y are actually moving together to get to that location. So thank you again, guys. I hope this video has been informative, and we will catch up in the future.